Hello, Chris Clements again, here to chat with you about percent composition. So let's go ahead and get started. You know that a percent is always parts of a whole, and then you multiply by 100 to do a percent. So percent is short for per centum, Latin words, which translate as by the hundred. And that means it's part of a whole. So if I give you a little simple problem, if there are 10 people in a room and 4 of the folks have blue eyes, what percentage of people have blue eyes? And you should be thinking to yourself or saying out loud, whichever you wish to do. You probably just did that in your head, and you would say 40% of the people have blue eyes, because that was an easy mathematical problem. You did 4 divided by 10 in your head. You should know that that is 4/10 or 0.4. Multiplied by 100 is 4t, and put that little percent sign on the end. You're accustomed to doing that. We're not going to do anything terribly different from that in these problems. The composition part means you need to know the chemical formula of the substance you're dealing with, and you also need to know how to calculate a molar mass. I taught you previously how to calculate molar masses, and we will do that again and again and again as we go through these problems. I believe I have 4 practice problems for you on this. So when we have percent composition, we have essentially 3 very, I'd say, predictable steps. We have to write the formula of the substance, we have to find that substance's molar mass, and then we have to determine the percentage of the part in question. Not always are we asking for the percentage composition of the entire compound. If you're asked for percent composition, you are asked for the percentage of every element that makes up the compound. If you're asked for just a part of the compound, you don't have to worry about the percentages of the other parts of the compound. So let's start with problem number 1, which is determine the percent composition of water. Not a terribly challenging formula to write, hopefully, but step 1 is to write its formula. And you should indeed have written H2O. Step 2 is to determine its molar mass. So recall how I taught you to calculate molar masses, and that is to write down each element that comprises the formula, in this case H and O, write them on separate lines. Look at your subscripts to determine how many of each element you have. We have 2 H's and 1 O, and then multiply those numbers by their respective average atomic masses from the periodic table. So we'll have 2 times 1.01 equals 2.02. Make sure you get that extended value. And for oxygen, we'll have 1 times 16.00 equals 16.00. We then add those 2 extended values together to get a molar mass of 18.02 grams per mole. The next step is to find the percent composition. In this case, that means the percentage of hydrogen and the percentage of oxygen in the compound. Well, the reason I have you do your molar masses as I have you do them is so that it makes it easy for you to actually do the math. You're going to take each extended value, the 2.02 and the 16.00, and divide by the molar mass, 18.02, and then multiply that number by 100. When you do so, you're going to see that you have 11.2% hydrogen and 88.8% oxygen in water. Percentages that are all given for the whole substance should always add to equal 100, as 11.2 and 88.8 add to equal 100%. So pat yourself on the back. You did a percent composition problem. Let's take a look at problem number 2, which is determine the percent composition of aluminum carbonate. A little more challenging formula for you to write. So look at your periodic table. You have aluminum. You should be able to deduce its charge as 3 positive. Carbonate, if you need to, use your cheat sheet for polyatomic ions, and you have CO3 with a charge of 2 negative. Do your crisscrossing business, and you have as a formula Al2 parentheses CO3 parentheses 3. Your next step is to determine the molar mass. Notice we're doing the same thing as we did previously. Step by step, same steps. So I'm going to write out Al for aluminum, C for carbon, O for oxygen. I look at my formula, I see that I have 2 aluminums. Make sure you distribute the 3 outside of the parentheses through the parenthetical expression so that you have 3 carbons and 9 oxygens. look up their average atomic masses. So I'll have 2 times 26.98 to give me an extended value of 53.96. 3 times 12.01 to give me an extended value of 36.03. And 9 times 16.00 to give me an extended value of 144.00. I add all of those extended values together and I get 233.99 grams per mole. And you guessed it, we're now going to find the percentage aluminum, the percentage carbon, and the percentage oxygen in the compound. So I take each extended value and I divide by the total molar mass. So for the aluminum, I'm going to take 53.96 divided by 233.99 times 100, and it gives me 23.1% aluminum. For the carbon, 36.03 divided by 233.99 times 100 equals 15.4% carbon. For the oxygen, 144.00 divided by 233.99 times 100 gives me 61.5% oxygen. And lo and behold, if I add 23.1% to 15.4% to 61.5%, I do get 100% for my total. Sometimes it can be a little off, just depending on rounding. You guys are noticing, I imagine, that I tend to use 3 significant figures in everything that I do except average atomic masses. Problem 3. A compound contains only copper and chloride ions. It is found to be 47.3% copper. Determine the formula of the compound. This one's a little more complex, but not too bad. It actually probably involves less work. Now, if I tell you it contains copper and chloride ions, then you have to determine what the possibilities are for the formula. Think about the fact that copper has 2 possible charges, 1 positive and 2 positive. Chloride ion is just Cl, 1 negative. So your choices of what the formula can be are CuCl and CuCl2. And hopefully you guessed it right. The next step is to calculate the molar masses of both of those possible formulas. So in CuCl, I'll have 1 times 63.55 equals 63.55, of course, and 1 times 35.45 equals 35.45. I add those together and I get 99.00 grams per mole. For the CuCl2, I have 1 times 63.55 equals 63.55, and 2 times 35.45 equals 70.90, to give me 134.45 grams per mole. Now remember, in this problem, I gave you the percentage of copper, and I said it was 47.3% copper, and I asked you to determine the formula of the compound. I don't care what the percentage of chloride or chlorine is in the compound. I only care about the copper. So now that I've found my molar masses of both possibilities, I then determine the percentage of copper in each. Notice I don't care, again, about the percentage of chlorine or the chloride ion. So I'm then going to take my total amount of copper in CuCl, which was 63.55, divided by the molar mass of CuCl, 99.00, times 100, and I get 64.2% copper. That doesn't seem to match my given 47.3% copper. So gee, I'm betting it's the other formula. Let's check it. CuCl2's total amount of copper is 63.55 divided by the molar mass, 134.45 times 100, is indeed 47.3% copper. So my answer is CuCl2. And our fourth problem, a compound is known to contain 41.7% magnesium. Determine if the compound is magnesium fluoride, magnesium hydroxide, or magnesium oxide. So, again, step 1, you got it, write your formulas. Magnesium fluoride is MgF2, magnesium hydroxide is Mg parentheses OH parentheses 2, and magnesium oxide is MgO. Remember, magnesium has a charge of 2 positive? So think about that with each of those. My next step, find the molar masses of each of those 3 compounds. So I'd suggest you pause the PowerPoint at this point. You've done several molar masses with this particular podcast, and come back to it when you're ready to check all of your molar masses. Okay, I'm assuming you're ready. And in magnesium fluoride, I have 1 times 24.31 equals 24.31. And for fluorine, 2 times 19.00 equals 38.00 for a molar mass of magnesium fluoride that is 62.31 grams per mole. For the magnesium hydroxide, I have 1 times 24.31 equals 24.31. 2, because I distributed the subscript outside of the parentheses, times 16.00 for the oxygen equals 32.00. And I distributed the 2 through the parentheses for the hydrogen as well, so I have 2 times 1.01 equals 2.02. My sum is 58.33 grams per mole for the magnesium hydroxide. For the magnesium oxide, 1 times 24.31 equals 24.31, and 1 times 16.00 equals 16.00 for a molar mass of magnesium oxide that is 40.31 grams per mole. Now recall in this one I gave you the percentage of magnesium in the compound that we don't know the identity of yet. So what you're going to do next is find the percentage of magnesium in each of these 3 possible compounds. You don't have to worry about the fluoride ion in the magnesium fluoride. You don't have to find its percentage. You don't have to worry about the oxygen or hydrogen in magnesium hydroxide. You don't have to worry about the oxygen in magnesium oxide. Just find the percentage of magnesium in each one. Pause the PowerPoint, come back to it, and see if you pegged it. Okay, as you see on this particular slide, magnesium in magnesium fluoride is 39.0%. In magnesium hydroxide, it is 41.7%, and in magnesium oxide, it is 60.3%. Which one matched the given information? Oh my goodness, it was magnesium hydroxide. Bravo, you've done 4% composition problems. So now you get to practice, 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 practice. Alrighty, hope you have fun doing it. Thanks for listening, as always. Hope you have a great day. Bye-bye.